Hello, this is CSM16A, and we're going to walk through one of the questions on Work6's worksheet. So this question is about 2D resistor touchscreen, and I am not going to speak too much again about how resistive touchscreens work, but you can see resistive touchscreens very widely used in real life, so there's value learning it. For example, your McDonald's ordering machine, or notably Nintendo Dual Screen 64, uses 2D resistive touchscreen. So let's look at what the problem description says. So last week we were talking about 1D resistor touchscreen, which is based on a voltage divider system that we'll talk about again later. And in this worksheet, we'll be making a 2D resistive touchscreen that will serve the purpose of dispensing you drinks. And we also have a link for a lecture note here about the physical model of a 2D resistive touchscreen, which is the part that I'm not going to give a mini lecture about, but let's just walk into the problem so we can continue discussing resistive touchscreens without the need of mini lecturing about what a 2D resistor touchscreen is. That sentence was supposed to be said as, if you don't know what a 2D resistor touchscreen is yet, we'll be exploring it during the problem, but it will be nice if you have some prior ideas, because this is a question that assumes you already know a little bit about 2D resistor touchscreens. Alright, so our first question, we're going back to a more fundamental section of nodal voltage analysis, which is to find the voltage V out as a function of our touch and our rest. So we can really quickly see that this structure resembles a voltage divider. Which you can say that the voltage that it's outputting is equal to the fraction of the original supplied voltage, and the fraction is written as the voltage, the resistance that this V out voltage is over, divided by the sum of resistors that are in series that are receiving this supply of voltage source. So that'll be our rest plus our touch. Once again, this is a familiar formula of a circuit called voltage divider, and the reason why it's called voltage divider is because it can divide the voltage that the voltage supply provides into a fraction of it across each of the resistors. So now that we have went through voltage divider again, let's move on to the second part of the question. Moving on, how do voltage dividers even relate to what we're building in this circuit anyways? And this is a rhetorical question, it seems. Given the circuit below models finding the y direction, which means the y direction of a 2D resistive touchscreen, does it actually matter whether we replace R1 and R2 with open circuits? It says R2 here. You're blind if you see this as R1. I'm very sorry about this. Find the equation for the voltages at each node, which is noted as UIY, as a function of Vs, R touch, and R rest. When it says model the voltage as an equation or as a function of Vs, R touch, R rest, we might have gotten a hint about whether we want to use the voltage divider in here, but let's hold off from that general feeling until we actually get an evidence for how to use that knowledge that we just got about voltage divider. So once again, the question is asking, does it actually matter if we replace these resistors with open circuits? So what is the difference between putting a resistor and putting an open circuit here? Well, actually, before that, let me just briefly explain what do we mean by finding the y direction here, so we do really understand the premise of this question prompt. So a 2D resistor screen, or resistor touch screen, should locate your touch point. And that is what a touchscreen is expected to do. I know, you might be saying that. But how exactly do we locate this touch point? In this case, we're using a Cartesian coordinates to locate your touch point. Which means, whenever my touch screen receives a touch, such as if I touch here with my pen, or touch here with my pen, the resistor touchscreen should sense the touch at some specific Cartesian coordinate of its entire screen. And this part of the circuit is supposed to figure out the y coordinate of the touchscreen. Which is what we meant by finding the y direction. Well, now that we have this brief review about how 2D resistor touchscreens work, we should probably worry a little bit about, does it matter if we replace R1 and R2 with open circuits? Okay, so what's the difference? What's the difference between putting a resistor and putting an open circuit here? And the reason why we're asking this question is because the question asked, does it matter to replace a resistor with an open circuit? So in other words, we're being asked, does replacing the resistor with an open circuit change the circuit a little, or does not pose any effect to our current circuit? Well, an open circuit has no current flowing across it. But a resistor might have a current flowing across it. So, if I want to replace this resistor with an open circuit, I have to prove that the nodes around the resistor or the node that the resistor is across have the same voltage. And let me explain why we have jumped to this step. Say that I have a node here called U4 and another node here called U5. But each node has equivalently 5 volts of voltage. I know that current is supposed to be the rate of change of charge over time that's flowing from a node to another, because electric current flows from one node to another when there is a potential difference. But there's no potential difference between U4 and U5, because they all have the same electric potential, which we know is 5 volts. Because there's no potential difference, there's no current. So this is 16A is not a physics class, and I will stop at the surface level explanation. But if you want to think about this in a physics perspective, what you can think of is, I have water at 5 meters high and another place with water at 5 meters high. And imagine that electrons here are actually water trying to flow across 2 locations. Well, I have water at the same exact height, which means water wouldn't naturally just flow from one place of a same height to another place of same height, because there's no gravity that's pulling the water down. But if I change the location the water is going towards to be a little bit lower, then there's gravity pulling water from a higher place to a lower place. And a very similar thing is happening to the electric phenomenon of no potential difference equals no current. Alright, so that's a very brief and informal physics lesson that you will not be using in 16A, but that's a physics perspective towards why there's no current when there's no potential difference. So, is there actually no potential difference across the nodes of R1 and R2? Well, we can do an experiment. Say that I am just going to take the resistors away with an open circuit. So my circuit becomes everything I have above, but deleting R1 and R2. So I'll have I believe it's our rest at above, and our touch at below. I do this a couple of times, 3 times to be exact, because I want 3 pieces of this to happen in my circuit. Oops. And once again, there was a R1 and R2 in between these nodes. I'm replacing them with an open circuit. And keep in mind that these nodes above all have the same voltage Vs, and the nodes below are all linked to the ground node, which I'll write as an upside down triangle here because it's easier. Actually, doesn't this look a little similar to what we have in part A, where we see that each branch of this circuit is a voltage divider. Each branch of this circuit is a voltage divider, and each branch of this circuit is a voltage divider. So essentially, we're putting 3 voltage dividers in parallel, and because they're in parallel, the amount of voltage across the node above our rest and below our touch is always Vs minus 0, which is a voltage difference of Vs. So once again, say that the nodes here are U4y, U5y, and U6y. Then we already know that through the voltage divider knowledge, U4y equals U5y, which is equal to U6y. And that is equal to, once again, Vs times our touch over our touch plus our rest. Alright, so what if I add the resistors back into the open circuit now? If I add the resistors back, then what happens is, because U4y and U5y are still having the equivalent amount of voltage, there's actually going to be no current flowing through the resistor in the middle. So in the end, replacing the resistor with the open circuit is a fine choice. And the reason why is because there's no current flowing through the resistors, R1 and R2. Okay, so that's a summary of how to solve part B. Now let's try to look at part C. Given the circuit that models the x direction, which is finding the x coordinate of the touch point, does it matter if R3 and R4 are there? But actually, we see that this circuit, I'm going to show you something really cool about this X circuit. I'm going to take a screenshot of my circuit first for X, and I'm going to paste it here, and what I'm going to do later is to rotate. Oh wait, I cannot rotate in this version of OneNote. But if I rotate it in the oh yeah, here it is. Okay, if I rotate it in the in the vertical direction, I see that this circuit is exactly the analogy to our circuit that is finding the y touchpoint coordinate. So the circuit for finding the x direction, x coordinate of the touchpoint, and the circuit for finding the y direction of the y coordinate of the touchpoint is actually working similarly. And therefore, what happens in the end is that R3 and R4 also don't have current across them. And this means they can be modeled as open circuits. Because open circuits also don't have current flowing across them. Now I have to. So let us remember that the original intention of this problem is to build a drink dispenser, where you might have this grid-like resistor touchscreen that could look like a button with 9 options, or a panel of 9 buttons. And depending on which button you get, or which button you press, you might get a slightly different drink that is going to be dispensed. So now, we are writing each drink's information in coordinate form to show which point they should be at. And this is in the coordinate order pair x comma y, where x denotes the voltage in x direction and y denotes the voltage in the y direction. Let the variable m represent the value of your middle node's voltage. First, solve for each node voltage now that you are given real values of them, and then we can try to fill these in. But while solving for the value m is not in the part of the question, so I'll deal with that later. For now, what I'm going to do is first try to fill things on. So, first of all, I know that the x direction and the y direction of the resistor touchscreen works like this, where there is a voltage source linking to the original linking to the entire panel, and this is the x direction, which is horizontal. Meanwhile, I also have a vertical circuit that I just skimmed from part B, and it has the voltage source linked this way. So I know that when I'm at the top, I have a higher y, or I have a higher voltage in terms of y coordinate. And when I'm at right, I have a higher x coordinate, which means I have a higher voltage at the x direction. So now that we have suited our panel into the resistor touchscreen setup, which you can see from part C and part D again, we can start filling in things. So first of all, what's going to happen to the black T is 0, 0, so it has to be at the bottom and at the left. And as a sanity check, sprite, which is m, m, must be somewhere that is middle in x and middle in y, so that would be straight in the middle of this 3x3 cell. And Vs, Vs then should be at the top right. Now let's fill downwards. This slot is where I have Vs for x direction, and I'm at the middle node in terms of the vertical direction, so this should be Vs, n, which is ripple. Following a very similar logic. This is where my x-coordinate voltage is Vs, as is directly linked to the node of Vs, and I am also at the ground node for the y voltage. So this should be Vs, 0, which is green T. And now we can fill in the rest of the cell with a very similar logic. A tip I would suggest about solving this kind of question is to first write down the coordinate on the cell and then turn them into letters, because that will turn them into words, because that will probably help you a little. So this is a general appearance of the cell based on the general direction of things we have went through. So what is the value of m then? Well, m is supposed to be the middle x voltage and the middle y voltage, and we also know that each of the resistors rest and touch all have 1 kilo ohm. So m is equal to, once again, we're going to invoke voltage divider. M is equal to Vs times our touch over our rest plus our touch, which is equal to 8 volts times 1 kilo ohm over 2 kilo ohm. And that is equal to 4 volts. Let me put this a little bit above so it's not so crowded. Alright, so now that we have finished part D, let's move on to the last part of the question, which is part E. Suppose your good friend Bob miraculously messes up your new 2D resistive touchscreen. One of the resistor values has been swapped out for a value twice its original value, which means one of our touch or our rest here has been swapped out with some resistor twice its resistance. How will this impact your touchscreen? I will go through this question conceptually because writing down something for this question is essentially the same as having you directly read the solution from the solution files. So let's go back to these. Let's go back to just the Y configuration and discuss what happens here. So originally we were working with this circuit with the version of this circuit with open circuits, where we have 3 voltage dividers, and the entire premise at which there is no current across the resistor R1 and R2 is that the middle nodes are the same. And the reason that the middle nodes are the same is because we use the voltage divider and the proportion of the supplied voltage supplied to these single nodes are the same. And the further reason of that is because the proportion our touch over our touch plus our rest is the same. So now if today I switch one resistor with twice its original, say I switch up one of the bottom ones, then what happens is U5Y has a different voltage from U4Y and U6Y, and therefore the resistors will also actually have current that flows from U4Y to U5Y, and then current from U6Y to U5Y, because U5Y has a less voltage node, has less voltage at its node, or lower electric potential lower electrical potential at this node, and that introduces potential difference between U4Y and U5Y, which causes current to flow from U4Y to U5Y, or from a higher potential node to a lower potential node. So if we switch up the bottom node if we switch up any bottom resistor, this ratio changes, and thus not every node has the similar voltage. And because not every node has the equal voltage, you will not have equal potential across each node, and you will have current flowing through the resistors R1 and R2. And since there are current flowing through R1 and R2, you cannot model them as open circuits because there is supposed to be current flowing through these two nodes. So hopefully going reverse in the direction helps you understand the question a little more and what it's asking. You might also ask whether changing the above resistor here matters or influences the circuit, but as long as you influence the ratio of R touch to R touch plus R rest, which changing the top resistor does, it will still make one node's voltage higher than the other and introduce current into the resistors R1 and R2. So the short answer to part E is it will impact your touchscreen by making it not as originally intended in terms of how to detect the touchscreen voltage. Because the way we detect touchscreen voltage is based on the voltage that we find in the X direction and Y direction. For example, I know that orange juice is at the top left. Am I counting the directions right? Top left corner, because it has 0 voltage in X direction, which means it must be aligning to the left, and it has the most voltage possible in the Y direction, which means it must be at the top node where it's directly connected with VS. But if I today have a different resistor structure such that there is current flowing through R1 and R2 here, then I cannot use the same convenient way to determine what the coordinate of a touch point is according to its voltage. So it will impact your touchscreen by making it less convenient. Alright, I will stop the recording at a place where a screenshot is available. And hopefully that solves your questions that you've had on this question.